Hello students, science is about exploring the truth and facts. Scientists always speak on the basis of scientific facts. So with this thought, let us continue today's discussion. So far in this chapter, we have discussed that mixtures can be of several types. Depending on the nature of the component, we can classify mixture into two types. One is your homogeneous mixture and the second one is your heterogeneous mixture. As you know, homogeneous mixture are those mixture which are having a uniform distribution throughout. Heterogeneous mixture are those type of mixture which are having non-uniform distribution throughout the bulk. And we were discussing one such type of homogeneous mixture, that is true solution. And as you know, a true solution has two components. One is your solute and the other one is solvent. Together they gives rise to solution. In the previous class, we had discussed that depending on the physical state of solute and solvent, we can have varieties of solution. And here are some of the example in front of you. I have on your screen a solution of copper sulfate in water. Here, copper sulfate is your solute and water is your solvent, and we are getting copper sulfate solution. And similar way, we can have varieties of solution. For example, when iodine is mixed with alcohol, it gives tincture of iodine. Similarly, sugar when dissolved with water, it can give sugar solution. So here what we observe, the solute is solid and the solvent is liquid. But we can have different type of solution. For example, if you dissolve carbon dioxide in water, we will have aerated drinks that commonly we use in our day-to-day life as cold drinks. Although it's not good for health, but still commercially a lot of varieties of cold drinks are available. So this is an example of your true solution. Now I want to keep a situation in front of you. That is, I am holding two test tube in my hand. To my left, observe it carefully, and to my right, another test tube. If you observe it carefully, the color of the first test tube, the solution of the color of the first test tube is slightly fade, whereas the second test tube, the color is deep. Can you tell me the reason behind it? And if you are wondering what solution I am holding, it is copper sulfate solution. As you can see from the color of the solution, it is blue in color. In the left, it is light blue, and whereas in my right, it is deep blue. You must be thinking, what is the reason behind it? The reason being, in my test tube that I was holding in my left hand contains a very few amount of copper sulfate crystal, whereas in the second test tube, it contains comparatively more amount of copper sulfate crystal. So here, the two terms that I introduced, one is comparatively less and comparatively more. These two terms are relative. That means I am indicating here the amount of solute that I have dissolved in that particular solution. So, depending on the amount of solute that has been dissolved in a given volume of solvent, we can have two different type of solution. One is your unsaturated solution and another one is saturated solution. What is unsaturated solution? If a solution can dissolve more amount of solute at a given temperature, we call it as unsaturated solution. And if a solution cannot dissolve more amount of solute at a particular temperature, we call it as saturated solution. For example, from our day-to-day life, unsaturation and saturation can be understood in this way. If you are feeling hungry and if you are provided with a less amount of food, then still you can grab more amount of food. That is your unsaturation level. But if your stomach is completely full, you cannot consume more amount of food. That gives a saturation level. That means we can understand it from here clearly that a solution which contains the maximum capacity, that is capable of dissolving a particular amount of solute, we call it as saturated solution. Unsaturated solution is that solution which can dissolve more amount of solute at a particular temperature. That means it has not reached its maximum capacity. So we'll call it as unsaturated solution. So here one thing that we are discussing is amount of solute. That means a solution is categorized as saturated or unsaturated depending on the amount of solute that has been dissolved in a particular volume of solution. So, if a solution contains maximum quantity at a particular temperature, we call it as the solubility of that substance. That means the solution has dissolved its maximum quantity. It contains the maximum amount that it can be dissolved in it. So, we call that maximum quantity that can be dissolved in a given volume of solvent at a particular temperature, at a fixed temperature, that is called as your solubility. Different solute has different solubilities at the same temperature. That means if I take sodium chloride, if I take potassium chloride, both of them at the same temperature will have different solubilities. What does that mean? That means if I take 100 gram of water and I add sodium chloride to it, in another beaker also if I take 100 gram of water and I add potassium chloride into it, the amount which can be dissolved, the maximum amount that can be dissolved for both the substances or both the solute will be different, indicating that different substances will have different solubilities at a particular temperature. Similarly, if we take a particular solute, the solubility will vary the temperature. For example, if I am preparing a solution of sodium chloride at room temperature and if I am preparing a solution at higher temperature than the room temperature, then the amount which can be dissolved at room temperature and the amount which can be dissolved at higher temperature will vary, indicating that solubility varies as the temperature changes. Here we need to note there are two factors on which solubility can be varied. One is your pressure, another one is your temperature. In standard 9, we will specifically discuss about two types of solution. One is solid in liquid and another one is gas in liquid. So let us discuss how solubility of solid in liquid varies with temperature and pressure, how solubility of gas in liquid varies with temperature. As you know, solid is a dissolution process. Here what you see, if you increase the temperature, the solubility of solid in liquid gradually increases. But if you decrease the temperature, that means if you prepare a saturated solution a little higher temperature than your room temperature and allow that particular solution to cool down, what you will observe? You will observe as soon as the solution cools down, you will observe that crystal of that particular solute will settle down at the bottom of the beaker or bottom of the container. Similarly, if you take the case of pressure, as you have already studied in chapter 1, the liquid and solid cannot be compressed. That is why by changing the pressure, there will be no effect on the solubility of solid in liquid. So here what we can summarize, that as the temperature increases, solubility of solid increases in liquid. As the temperature decreases, solubility of solid decreases in liquid, and pressure has no effect on the solubility of solid in liquid. Another example that we will take is about gas in liquid. The common example is your cold drinks bottle. The moment you open the seal of a cold drinks bottle, what do you observe? Gases coming out or gases escaping out. What does that mean? That means the gas inside the bottle was stored under high pressure, indicating that solubility of gas increases as the pressure increases. That is why aerated drinks, the bottles are stored under high pressure. Whereas if you release that bottle, if you lose that lid, what you will observe? That gases escaping out, indicating that solubility of gases in a particular liquid decreases as you decrease the pressure. Coming again to temperature, if you increase the temperature of a gas in liquid solution, for example, as we know, oxygen remains dissolved in water, and because of the dissolved oxygen in water, aquatic animal can survive in water. They can respire because of the dissolved oxygen which is present in water. Now I am putting a situation in front of you. Can a fish survive in hot water? Absolutely, the answer is no. What is the reason behind it? Because in hot water, the amount of oxygen dissolved is less. But in comparison with cold water or normal water, the amount of oxygen is more, indicating that as the temperature increases, solubility of gas in liquid decreases. That means the amount of oxygen dissolved in hot water decreases as the temperature increases. And that is why fish cannot survive in hot water, or aquatic animals cannot survive in hot water. So what can we summarize here about solubility? Effect of temperature and pressure on solubility of gas in liquid. As pressure increases, solubility increases. As pressure decreases, solubility also decreases. About temperature, as temperature increases, solubility decreases. As temperature decreases, solubility increases. Now, we always discussing here in the previous slide, we discussed about the amount of solute. Whatever we discussed here is about a relative term. It's not a concrete data or factual data or mathematical data. So the amount of solute that is present in a given volume of solution can also be expressed mathematically. That is what we call it as concentration of a solution. So how do we calculate or how do we express concentration of solution? There are several methods. But in standard 9, we will study about few of the ways to express the amount of solute that is present in a given volume of solution or given mass of solution. What are those ways? The first way is your mass by mass percentage of a solution. How do we express it? The formula for it is mass of solute divided by mass of solution multiplied by 100. This is the first way. Second way, mass by volume percentage. How do we express it? What is the formula of it? Mass of solute divided by volume of solution multiplied by 100. The third way, volume by volume percentage. How do we express it? Volume of solute by volume of solution multiplied by 100. So these are the three basic ways in which we can express the concentration of a solution. That means how much quantity of solute is dissolved in a particular amount of solution. So let us solve some numerical to understand it in a better way. So here is a question in front of you. A question is, a solution contains 40 gram of common salt in 320 gram of water. Calculate the concentration in terms of mass by mass percentage of the solution. You can read that question very clearly. Take a moment and try to solve it. I am bringing you the solution to that problem. As you know, from the question we can note that mass of solute is 40 gram, mass of solvent is 320 gram, and as all of you know, mass of a solution will be always the sum of mass of solute plus mass of solvent. That means mass of solute is 40 gram, mass of solvent is 320 gram. So together the mass of the solution becomes 360 gram. Mass percentage of a solution can be expressed as mass of solute divided by mass of solution multiplied by 100. Substituting the values, 40 divided by 360 multiplied by 100 gives us 11.1%. So the answer will be, the concentration of solution is 11.1%. I think it's clear to all of you. So to understand little better way, let us solve another example. The question is, to make a saturated solution, 36 gram of sodium sulfate is dissolved in 100 gram of water at 293 Kelvin. Find its concentration at this temperature. Take your pen and paper and try to solve it. I am bringing you the solution to this problem. As all of you can see on your screen, that mass of solute is 36 gram. Mass of solvent is equal to 100 gram. Mass of solution is equal to mass of solute plus mass of solvent. That means 36 gram plus 100 gram will give us 136 gram. So how do we express it in terms of percentage? Mass of solute divided by mass of solution multiplied by 100. Substituting the values, 36 divided by 136 multiplied by 100 gives us 26.47%. That means the concentration of the solution is 26.47%. So dear students, that's all about a true solution and its classification. Now let us discuss about the other type of mixture, that is your heterogeneous mixture. And as you know, in heterogeneous mixture there are two categories. One is your suspension and the other one is your colloidal solution. And this categorization has been done on the basis of the particle size. In case of your suspension, the particle size is greater than 100 nanometer, and in case of colloidal solution, the range is from 1 nanometer to 100 nanometer. So let us discuss more about suspension. So what is suspension? A suspension is a heterogeneous mixture in which the solute particles do not dissolve but remain suspended throughout the bulk in the medium. So here what you will observe, unlike your true solution, the solute particles will not dissolve in the solvent, but they will remain suspended in the bulk. And as the particle size is big, that is greater than 100 nanometer, it will be visible to our naked eyes and we can distinguish between the components of a suspension. Basically, in case of suspension, you will observe that the component forms different layers. As they form different layer, we can distinguish between the components very easily. And as the particle size is very big, that is greater than 100 nanometer, they can be easily separated using a filter paper. And due to the big size of the particle, they get attracted more easily by gravity. And if you will leave the suspension undisturbed for certain time, you will observe the suspended particles will gradually settle down at the bottom. And you can see a clear separation between components in the suspension. Example of suspension are chalk powder in water, talcum powder in water, sand in water. So dear students, let us understand about suspension and its properties through an activity. Let us prepare a suspension and let us understand the properties of suspension. So dear students, let's make a suspension of water and sand. So I am holding a beaker containing some water and to it will add some sand. So as you can see, I have taken some sand and will add into it. And if you stir it properly, you will see by stirring it, the particles becomes suspended. Whereas the moment I leave it undisturbed, you can see that the sand particles is settling down. What is the reason behind it? The reason being, as the particles are big enough and heavier, they will settle down at the bottom. Another experiment that we can do is your chalk powder and water. So I'll take a test tube and to it I'll add few chalk powder, a few amount of chalk powder into it, and to it we'll add water. So as you see, the appearance of the mixture becomes slightly milky, and if you allow light to pass through it also, it will not pass through it. The moment I am shaking the test tube, you can see that the particles becoming suspended. But if I leave it for undisturbed for certain time, gradually you can observe the chalk powder is settling down, indicating that the nature of this mixture is highly unstable. Gradually, if you can observe that the chalk powder is settling down at the bottom and a clear solution is forming at the top of that chalk powder layer, indicating it's highly unstable and the solute particle will settle down if it is kept undisturbed for certain time. Now we will verify that whether a solute particles of a suspension can be separated using a filter paper or not. So for that, we'll take a filter paper and a funnel. So here is the setup for that. So what we'll do here, that we'll do this experiment with your sand and water. So dear students, let us check whether the solute particle of a mixture of sand and water can be filtered using a filter paper or not. So we'll transfer this mixture into the filter paper and we'll examine whether the solute particles are getting passed through the filter paper or getting deposited on it. So I'll transfer slowly this mixture into the filter paper, and if you can see that the sand is getting deposited on the filter paper and slowly the liquid is getting transferred into the test tube, indicating that the solute particles are big enough and they will not pass through a filter paper. That means the solute particle of a mixture of suspension can be separated using filter paper. So from the activity, it is clear about the properties of suspension. Now let us discuss about the other type of heterogeneous mixture, that is your colloidal solution. As I had already mentioned, that colloidal solution, the particle size is from 1 nanometer to 100 nanometer. And although the size range is greater than your true solution and less than your suspension, but these particle size are not visible to our naked eyes. And because of that, although your colloidal solution are heterogeneous in nature, but they appears to be homogeneous. So it is very difficult to distinguish between a true solution and a colloidal solution because of the particle size. In case of colloidal solution, that is actually heterogeneous but appears to be homogeneous as the particles are uniformly spread throughout the solution. Like your true solution, colloidal solution also, the particles are uniformly distributed and the particles are highly stable in nature because these colloidal particles execute a zigzag random motion, which is known as Brownian motion and which was observed by a scientist called as Robert Brown. He observed in case of pollen grains that there is a zigzag random motion because of which the particles never settles down. As the particles do not settle down, we call that colloidal solution are highly stable. Now let us look at the properties of colloidal solution. A colloid is a heterogeneous mixture. The size of particle of colloid is too small to be individually seen by naked eyes. Colloids are big enough to scatter a beam of light passing through it and make its path visible. About this property, we will have an experiment to understand how a path of light becomes visible when light is passed through a colloidal solution. And this phenomena of scattering of light when light beam is passed through a colloidal solution is called as Tyndall effect. And we will discuss about more by doing an activity. Here we have taken a solution of starch in water, and as you can see, when passing a beam of light through a starch solution, the path of the light becomes visible, indicating that starch in water is an example of colloidal solution, and as it scatters a beam of light, we can observe a beautiful Tyndall effect through that solution. Now you can see that how a colloidal particle scatter a beam of light and the path of light becomes visible. Coming to the next properties of your colloidal solution, that they do not settle down when left undisturbed for several times. That showing that colloidal particles are quite stable in nature. And here also, as the particle size is very small, they cannot be separated using a filter paper. This size particle will pass through the filter paper and cannot be get separated through a filter paper. It is similar to your true solution. As talking about true solution, like your true solution, colloidal solution has also two components. One is called as the dispersed phase and another one is called as the dispersing medium. Dispersed phase is the solute-like component, the dispersed particle in a colloidal form, the dispersed phase. And the dispersing medium is similar to the solvent in case of true solution. Here, the component in which the dispersed phase is suspended is known as dispersing medium, or in other term also we can say the particles which are less in amount and which are suspended in the medium is called as the dispersed phase, which is similar to a solute in case of true solution. And in case of true solution, the one component which we call as solvent, here the name is given as dispersed medium. And depending on the physical state of dispersed phase and dispersing medium, they can be categorized into several types. For example, if the dispersed phase is liquid and the dispersing medium is gas, then the type of colloidal solution is called as aerosol. And the example are fog, cloud, mist. The fog we see in winter or the cloud we see during rainy days. These all are example of your colloidal solution and the type is called as aerosol. So depending on the physical state, we can have 8 different type of colloidal solution. The table of those colloidal solutions are given on your screen and is very important to remember the type and the dispersed phase and the dispersing medium. So dear students, let's quickly recapitulate what we have studied so far and let's make a comparison between the different type of mixture, homogeneous and heterogeneous mixture. So let us compare between suspension, colloidal solution and true solution. Here is a table in front of you that shows the comparison between suspension, colloidal solution and true solution based on different properties. So depending on different properties, a suspension, colloidal solution and true solution can be compared as such. Particle size is greater than 100 nanometer in case of suspension. In case of colloid, the particle size is 1 nanometer to 100 nanometer. In case of true solution, the particle size is less than 1 nanometer. And because of that, the visibility of this particle, that means in case of suspension, the particles will be visible to naked eyes. In case of colloid and true solution, the particles will not be visible to our naked eyes. Nature: suspension is heterogeneous in nature, colloid is heterogeneous, and solution is homogeneous in nature. If you look at the appearance of this mixture, suspension is generally opaque, colloids are generally clear, and true solutions are transparent or it is clear. If you talk about the stability of the solute particles, suspension the particles settles down, hence it is unstable. In case of colloid, the particle will never settle down, hence they are stable, and true solution also, the particle will never settle down, hence they are also stable. If you go for filtration, a suspension can be filtered using a filter paper, a colloidal particle cannot be filtered using a filter paper, and in case of true solution, as we have already experienced that in the activity, that particles of a true solution cannot be filtered using a filter paper. And about Tyndall effect, that is scattering of light when light is passed through that mixture. In case of suspension, when the particles remain suspended in the medium, they will show Tyndall effect, that means Tyndall effect will be observed. And in case of colloidal solution, when light is passed through the colloidal solution, it scatters a beam of light and we observe Tyndall effect. But as true solution particle size is very small, we cannot observe Tyndall effect in this case. So this is so far we have studied, and let us quickly have a question answer session so that we can understand how far we have learnt in this chapter. So here is a question in front of your screen. A saturated solution of potassium chloride in water is prepared at 353 Kelvin and the solution is left to cool at room temperature. Explain your observation for the above process. What you need to explain it here is that the solution is prepared at 353 Kelvin. That means it is greater than room temperature. So if a true solution is allowed to cool down, that means if the temperature is brought down to room temperature, you will definitely observe that the extra amount of solute particles, that is the potassium chloride, which has been dissolved, will separate out in the form of crystals. The second question in front of you. Tincture of iodine has antiseptic properties. This is a solution made by dissolving. Which among the fourth option is correct? Option 1, iodine in potassium iodide, iodine in Vaseline, iodine in water, or option D is iodine in alcohol. And the correct answer is iodine in alcohol. So dear students, revise your chapter thoroughly, and the next class will continue with how to separate different components of a mixture. Till then, take care.